Derivative of inverse tangent x. So the graph of the arcus tangent x, or inverse of tangent x, it looks like in the figure here. So now let's go to the proof of the derivative. Let's say y is equal with a tangent, inverse tangent x. So let's write here. So this is how we can write the inverse of tangent x, but we can write even with the arc tangent x like it was here in the figures, for example. But let's use this denotation because mostly we use here in most of the books, so I'm using this denotation. And again, as I said, the derivative, the denotation for the derivative, we can use those two denotations interchangeably. We can use one or the other. Doesn't matter which one we want to use it. And let go. And now again, let's take a tangent both sides. And if I'm taking tangent both sides, I'm taking tangent y is equal with the tangent. Let me, because I waste a little more time on writing slowly. Tangent of x. But now we have here, let's write here tangent y. Again, we have here this function to denote this something because it's important function. And we have again the inverse function, and function is equal with the argument x. So because here is a tangent and its inverse tangent, so it is equal with the x. So we already have this equation, and this equation is very important for us later on to substitute. Therefore, I'm going here this one to write with one star here, and then we are going to use later on. But first of all, let's continue with the same color. So tangent y is equal with x, and let's take a derivative of this equation both sides with respect to x. And if we take a tangent y, its derivative is going to be secant square y. So it's a secant square y is equal time y prime, or derivative y is equal with then if we take a derivative of x is 1. If we divide everything by the secant square y by the secant square y, then this equation is going to look this way. Derivative of y is going to be equal with the 1 divided by secant square y. Secant square y. So we are here now. But again, we need some identity to change this secant square y. But first of all, again, I am going with the sine square. Let me go here with the sine square y, with the trigonometric identity. Sine square x plus cosine square x is equal with 1. Plus cosine square x is equal with 1. And what I'm doing here now, I'm going every whole equation to divide by cosine square x, everything cosine square x. I'm going to divide everything, whole equation. But here now let's go with a different. Here, for example, I divide by the cosine square x, cosine square x. Same thing, I'm going with the second term here with the cosine square x, cosine square x. And of course on this other side I'm going with the cosine square x. So all the three terms I am going to divide by cosine square x. And now here sine square x divided by cosine square x is a tangent square x. Is a tangent square x. And now here cosine square x divided by cosine square x is just 1. It is plus 1. And this is equal. But 1 over cosine square x, this is a secant square x. Secant square x. And now secant square x is equal to tangent square x plus 1. But now we have this scenario, secant square y. But first of all, because I have a y prime here, let me change the derivative with a different denotation. Let me write a dy over dx. So I will write here a dy over dx, dy over dx, and I'm going to change this denotation here is equal with 1. Instead of secant square y, I'm going to change a tangent square y, or 1 plus tangent square y. Because here the commutative property in addition works, is valid. Instead of write a tangent square x, I can write 1 plus tangent square x. And in this case, I'm writing 1 plus a tangent square y. Square y. And this is the last step for this proof, so I don't have to go any further. Dy over dx, so our derivative, which is a denotation for derivative, is equal. So let's just write this 1, and here 1 plus, but instead of a tangent square y, we already see this equation star, what we did here. Tangent y is equal with x, but the tangent square y is equal with x squared. So is equal with x squared. And now we already proved the derivative of a tangent x is going to be equal with 1. The derivative of a inverse tangent x is going to be equal with 1 over 1 plus x squared.